We're going to go ahead and get started. Next speaker is Zain Memon, who's going to talk about making maps.
Hello, everyone. Good afternoon. How's everyone doing? Great, great. I hope you guys got some caffeine on your way in, because we're going to move really quickly here. This is an extreme level talk, super extreme level talk. I will be moving quite quickly. Hopefully you were in the session before this talking about GIS, and so you have a pretty good understanding of what the basics are already, so that I can dig into some more deeper map concepts and things like that. And as extreme talks are wont to do, I will not actually be sticking to slides. This is my only slide. I'm going to be writing code, I'm going to be doing live stuff, and hopefully the demo gods will smile upon me today. We'll see how that goes. So let's get started. You're probably here to hear me talk about Google Maps. And I have to apologize, because I will not actually be talking about Google Maps at all. This is the only time we will see Google Maps in this entire presentation. And that is because this presentation is about how we can build our own Google Maps on open tools. Basically, by the end of this presentation, in the next 25 minutes or so, I hope to re-implement all of Google Maps on stage. We'll see how that goes. So, Google Maps. There's two different parts to Google Maps. When people say Google Maps, they often talk about both of them together. There's the JavaScript interaction library, and then there's the actual map data, the roads, the streets, the parks, the rivers, all of that. And those two things are very separate. There are other libraries, other JavaScript interaction libraries that will give you different sort of scroll bars, different sort of zooms, things like that. And then there's different base map layers that'll give you different colors for streets, different sizes, different fonts. And those two are completely separate. In fact, if you wanted to, you could use Google Map tiles with Bing Maps interaction, and vice versa. So by separating those two, we can start to talk about how we can replace each one of those individually. And we're going to start out talking about how to replace the map tiles themselves, the actual cartography data, the roads that we see on the screen. And the way that we actually do that is through what's called OpenStreetMaps. A lot of people here will be familiar with OpenStreetMaps, but for those of you who are not, OpenStreetMaps is an open effort to create a completely open source database of roads, of places of interest, of cartography data that we will be using to render our maps. Basically, everything that goes onto a Google Maps map, we can probably find in OpenStreetMaps. Pretty often, more often, it's more up to date, it's better quality, it's crowdsourced, all that good stuff. And so hopefully by switching away from Google Maps, we're not actually sacrificing data quality or anything like that, we're actually improving it. OpenStreetMaps is actually a very hippie movement, and so people in the open source community love it. This is a shot from Nairobi, where the Map Kibera project teaches students to go around with amateur GPS units and collect all of the data that will eventually end up in OpenStreetMaps. OSM has created this entire community of amateur map makers that are able to map out the most remote areas, even in the middle of Africa, where it would make no economic sense for Google to go out and draw roads for. The roads are sand and gravel roads which are walked on foot every day. It would make no sense for Google to go out there and map that, because it's not like they have internet out there. But OpenStreetMaps has maps out in the most remote of areas. And if they don't have maps for your area, if they're incorrect, you can go and you can update them. So our basic plan here is to load up some OSM data and generate some map tiles based on that we can then replace the Google Maps tiles with. A lot of companies have taken this approach recently. Foursquare is one of the biggest companies recently that has jumped on the OpenStreetMaps movement. All of their maps are now generated in-house using OpenStreetMaps data. A couple days ago, Apple announced the iPad 3. And when they did, they also announced iPhoto. And inside iPhoto, Apple is using OpenStreetMaps for the first time. Up until now, everything Apple has put out has been Google Maps. If you look at the iPhone, if you look at the older versions of iPhoto that show your photos on a map, that's all using Google Maps street tiles. Now they're on OpenStreetMaps. Unfortunately, they didn't actually they didn't attribute OpenStreetMaps with that data, and there's a lot of kerfluffling right now around that. But hopefully at some point Apple will own up that it is indeed OpenStreetMap data, and as the license asks them to, they will attribute that to OpenStreetMaps. Point being, a lot of really large companies are starting to move towards OpenStreetMaps, and the reasons are varied. The primary reason that very large companies move over to OpenStreetMaps is because Google has started charging for Google Maps. And for very large corporations, it ends up being a ridiculous amount of money, to where it actually makes sense for these organizations to implement mapping in-house rather than using Google Maps anymore. Does that make sense for startups? Does that make sense for people doing side projects? Well, actually it does, because the toolkits and tool chains around open source mapping can often be better than what you can get from Google Maps. So I'll talk a little bit about that now. I said that there were two parts to Google Maps. There was the cartography, and there was the JavaScript interaction library. So we can definitely replace the cartography with OpenStreetMaps. But what about that JavaScript interaction library? Google's done a lot of work to make that fast. They've done a lot of work to make it somewhat usable. How can we improve on that? Well, there's this library that we're going to be using today called Leaflet. Leaflet came out of a company called CloudMade, whose business it is to create alternative map tiles. And Leaflet is an open source library that's actually fantastic. It's very fast. It's actually a little bit faster than Google Maps is with large numbers of markers. And it's open source. You will never have to pay for it. And it has some really nifty technological geeky features. Like you can style every single part of the interaction library using CSS3. And that means when you put markers on the map, you can style those using the same CSS constructs that you use to style your page. And you can even use advanced things like CSS3 animations to create basically the next blink or marquee tag on your map. So here's what I hope we can build in the next like 18 minutes now. This is what I like to call a map sandwich. It's 3 different layers that are combined on the front end using Leaflet. The topmost layer is roads and highways and those associated labels. The one below it is a heat map. In this case, it happens to be a heat map of crime in San Francisco. The blue means it's safe, the red means it's dangerous, and the dark blue, purpley regions are in the middle. So, and right below that is the base map. That's the actual land, the coastline, all of that. I hope we can get through all 3 of those layers today. I'm going to be touching on the heat map layer the least, because 2 talks from now, there is actually a visualization on maps talk that will cover that way better than I can. But let's dig in primarily into the 2 layers that we're interested in that came from OSM and open source data. And that's the roads and the coastline data underneath it. Real quick, let's make a to-do list of what we want to get done here. I'm just going to start throwing stuff on here. We want to load OSM data into a database. We'll set up a JavaScript library, Leaflet. We'll create a map style, that style that I just showed you. We'll split it up into 2 layers, and that's the bottom base map layer and then the top roads layer. We're going to export it from our styling tool and turn it into what can be used as a library. We'll make tiles out of it. so that we can plug it into something like Leaflet or really any other JavaScript library that's out there. And then we'll combine it all using Leaflet. Looks like a lot of stuff, but hopefully we can burn through that pretty quickly. So firstly, I'm going to start loading OSM data. You get OSM data from a variety of places. The canonical source is OSM itself. They publish a file called planet.osm, which is a couple hundred gigabytes large. And every single time you want to get any of the updates happen hourly, you have to download the entire 200 gigabyte file again. So this is not the best way to actually get this data. There are a number of very nice people and companies that put up smaller dumps so that you can just get the areas that you're interested in or get slower updates or things like that. One of them is CloudMade. At downloads.cloudmade.com, they publish files by region, and you can go as small of a region as you want. So you can actually get something as small as just the state of California or just the city of San Francisco. My friend Mike Magursky from Stamen does the same thing in a little bit more number of formats. He has this automated tool that every few hours runs and gives you a dump of OSM data in a variety of different formats. So the one that we're going to be using here is the San Francisco Bay Area dump. And that's a really small map, but you can see that's the bounds of the data that we'll be using. It's the entire San Francisco Bay Area. It's much smaller than 200 gigabytes compressed. The specific data that I downloaded earlier, because I didn't want to depend on the Wi-Fi, was the XML OSM data and the coastline shapefile. So first, I'm going to load this XML OSM data into my database, into my Postgres database running PostGIS. That will let us actually do geoqueries on it and get that data out. So that's that file right there, SF Bay Area OSM.bz2. Oops. So I actually forgot to make the database. I will do that now. This is what it's like to pair program with me. I forget everything. Cool, so now we're actually loading in this data. This will take about 5 minutes, which is why I wanted to get this out as quickly as possible. But once this data is loaded in, we'll have an exact copy in the database of what OSM has in their database as to what the roads, the points of interest, the polygons, all those things are in the San Francisco Bay Area. So we're going to let this run. You might hear my laptop get really loud with the fan because I have a MacBook Air and it can't handle this shit. All right. I've been saying one term that some of you might not know, map tiles. I know this is not supposed to be an introductory course, but it's really important that people understand what map tiles are. So I'm going to take a second and go over a quick summary of what map tiles are. You all remember the days of yore when MapQuest would let us find directions between 2 points, and if we wanted to see the map for that direction, we saw one static image, and we'd click left and left and left to go pan around that map and see more of the map. These days, we have things like Google Maps, which let us drag around indefinitely and see the entire world on one canvas. And the reason that's possible is because of map tiles. A map tile is an actual image. It's usually 256 by 256 pixels in size. It's a PNG or a JPEG, and it's sent from the server to the browser and rendered onto the map. And that's what makes Slippy Maps possible is when you drag around on Google Maps, it loads in the map tiles for the new area that you're looking at. They're small images that get plugged into that viewport, and it flushes out the ones that you're no longer looking at, which lets you scroll indefinitely through all of your world, basically. This is a neat demo of how that works. So imagine the red rectangle is your viewport, and each of the gray boxes are tiles. As you move your viewport over, the browser, the JavaScript interaction library, will actually fetch tiles for the areas that you're going to look at, and it flushes out tiles that you're not looking at anymore. Pretty nifty. There's a library, by the way, called Mapstraction that abstracts out the APIs of a number of JavaScript interaction libraries like Google Maps, like Leaflet, like OpenLayers. It's really cool to use. You can check it out. It doesn't give you all the power of each of these individual libraries, but it gives you a nice API that lets you add markers, add layers in a unified way, and then switch between them. I wanted to touch on this a little bit more, but I don't think I'll have time. So I'm going to move forward off of that and take a look at how our load is going. Cool, it's still going. We'll get to TileStash in just a sec, but first, we're going to load up a program called TileMill. TileMill is a map design studio. It is an open source project out of guys in DC that basically lets you create your own maps and style them in any way that you want. So I'm going to create a new project here. I will call it PyCon Talk. And to this project, I will add a layer. Layers are things that go on the map, as the name implies. The data source I will use is the SF Bay Area coastline data that I previously downloaded from Mike Magurski's site. I wish I could make this bigger. Apparently I cannot. All right, so for those who can see this, this is a language that looks a lot like, whoops. This is a language that looks a lot like CSS. Let me figure out what that error was real quick. All right, well, I won't stick on that. This basically lets you load in things like shapefiles, OSM data from your database, things like that, and style it using a language that looks a lot like CSS. It's called Carto, and it supports most of the things that CSS does because it's actually forked from a JavaScript library called Less. Less is a project, if you're not familiar with it, that makes CSS better by adding things like variables and basically CSS on crack. So since my demo here failed, I'm going to go use cheat mode and go to the demo that I was looking at and styling beforehand. This is where I hope to get to in 5 minutes from now. What I've done here is I've styled all the land. That was the first data set that I loaded in. That was the coastline data that I got from Mike Magurski's site. I set the polygon fill to a color. It's a static color. And then I added in roads. So this was a second layer that I added in for a total of 2 layers. And the roads layer looks like this. It's, again, very simple. I gave it the database name, which is the database that we loaded all of the data into using OSM to PGSQL. I gave it a table, which is the table of all of the roads. It's called Planet OSM Line. And all of this is documented very well on the OSM site. And then I just hit save. After that, I was given 2 layers in this thing to style. I was given 2 IDs, CSS IDs, pound roads and pound land. By assigning styles to pound land, I colored the land. By assigning styles to pound roads, I colored the roads. And the updates are actually completely live. So for example, if I was to change the land color to white and hit save, it would actually refresh and show me that in real time. So that would have been a really cool demo if I didn't get that random error. I don't know where it came from. Oh, I do know where it came from. But I won't stick to it. We'll move on. If you were curious, I actually used the wrong CSS style here. This should be polygon-fill. And then if we were to zoom out and actually change our extents here. I don't really have time for this. So we will go with the cheat mode. Look, guys, we have a styled map. That was fun. Now, what can we do with this styled map? Most people would actually throw this onto Mapbox. Mapbox is a service by the same people behind TileMill that lets you throw all of your styles onto, that lets you throw all of your tiles onto their servers and serve them using their servers. What we're going to do in quick fashion here is export this to a Mapnik XML file. Specifically, these two other cheat mode things that I've created. This is just the base map that I will export to a Mapnik XML file called pyconbg.xml. And another one called Pycon Streets. All right, so now I have two XML files. If you're not familiar with Mapnik, Mapnik is a open source Python tool that you can use to style your maps and generate your own map tiles using OSM data. So what we just did was use TileMill as a Mapnik front end. Since Mapnik is a library, we use it as a front end to create the style, create the Mapnik XML files, and dump them out into this folder. How do we actually look at these? How do we invoke Mapnik? Well, there's this toolkit called TileStash. And I won't go too deep into TileStash, but it is essentially something that lets you create tiles out of anything, out of any sort of data. You can use an ORM to collect that data. You can use shape files, and it'll get chunks out of that shape files that correspond to map tiles, all that sort of stuff. It's powered by a config file called tilestash.cfg, which has a key called layers. That's the only important part. In that key, in layers, we're going to have 3 layers eventually. I have one in here already, the crime heat map. We're not going to go too deep into that. You guys know what that looks like. I showed you earlier. But in case you forgot, it looks something like, not like that. It looks something like a heat map. You guys know what a heat map looks like. We're going to add 2 more layers in here. The background. And hopefully, now that we've added this, at the BG endpoint, once we run this server, we'll have the Pycon background XML file that we designed in TileMill. So let's fire up the server for that. All right, so this is running on my local host with nothing but this config and the style.xml file that we saved, the pycon-bg.xml. So this is our base map layer. We're going to do the same thing for the streets, which we also exported earlier.
Why did the heat map show up?
Because we haven't actually put the heat map on there yet. The URL that we're looking at is localhost 8080/bg, which only shows us the background. The question, in case you didn't hear, was why didn't the heat map show up even though it's listed here? If we were to go to crime-heatmap/preview, then we would see the heat map. And there's our streets preview. And that's pretty looking, right? There's a transparent background underneath there so that we can see the heat map through it. And like I said, if you go to crime-heatmap/preview, you'll be able to actually see the crime heat map here as well. And again, these are just the color tiles. Now we have 3 different layers. We want to combine these 3 layers, the heat map layer, the streets layer, and the base map layer in the front end. So we look at Leaflet And it's really easy to do this in Leaflet. You include all your JavaScripty things. You include the 3 URLs for the 3 tile sets that you have. And you add layers to the map for each of these 3 tile sets. And I'll throw all of this code up on GitHub, so you don't need to furiously copy this down. You can just take a look at it once I throw it up. But once we do that, once we've added all 3 of these, we end up being able to fire up a server. And we have all 3 of them. If I actually disable caching here, you can see all 3 of them load dynamically. This is one of TileStash's features, by the way. It caches tiles automatically if you want it to. So there's the base map layer. There's the heat map being dynamically generated on my MacBook Air, which is crying in pain. And on top of it will come all of the streets with their labels, all of which can be styled endlessly in TileMill. So sorry, I covered a lot of technologies there. I was thinking I would go way faster than that, but I talked too much. So apologies, but I will throw all of this code on GitHub so you guys can check it out. If you have any questions, feel free to email me. If you have any trouble getting it to work, email me. Now it's time for questions. Yes, and please do use the mic up here.
Some good exercise that way. Hey, so what's the best way? I'd really like to ditch Google Maps, but my problem is I have a whole lot of addresses that I need to geocode to put points on the map. So is there a way to do that with OpenStreetMap data, or what's the best way to geocode?
There is. So there's actually open source geocoders available that will plug into your OSM data and let you do geocoding. Another really good alternative is actually MapQuest has APIs. You guys remember MapQuest? They're actually doing awesome stuff with open data and APIs. They've created some APIs with no usage limits. So you can hammer them all you want. And one of their APIs is a geocoder API that's actually fantastic.
Awesome, thanks.
What does productionizing something like this look like?
So to productionize something like this, you'd want to throw these tiles onto production-ready hardware, basically. That involves, for the base map and the streets, those don't change very often. So you'll throw those on something like CloudFront, or Mapbox offers a service that lets you upload directly from TileMill. So something like that. For the heat map, if you expect it to be either dynamically generated or changing often, you'd want to handle that yourself. TileStash is perfect for that. That's what TileStash was made for. So you'd set up a Python WSGI server that's pointing to TileStash, and TileStash will dynamically generate those tiles when they're not there, and it'll serve them out of a cache when they are there.
Cool. Thanks.
Do you have a favorite tool for pre-rendering tiles? Like if you just want to kick them out to PNGs and stick them on S3?
I do. I use TileStash for that too.
Okay.
This is a common trend. Once you like TileStash and you know what it does, every nail looks like something you can hit with the TileStash hammer. So to pre-render tiles for an area, there's a script called tilestash-seed that comes with TileStash. And you just run that with bounds, and it'll go through and basically act like it's hitting your server and generate tiles for that entire thing, and either load them into a cache or load them on disk.
This is more of a curiosity, but I know d3.js has some GIS features in it that render SVG on the client. It's probably too much data to do something street level like this, but just curious where you see that going, client-side SVG rendering of map data.
Yeah, it's cool. The D3 isn't an interaction library, though, so it won't give you this slippy map draggy interaction. You'd need to implement that yourself. But for static visualizations, I think D3 is great. In fact, even visualizations on top of this. I've seen some really cool examples where you have a slippy map like Leaflet underneath, and then D3 on top that's highlighting each of, for example, for every single state, there's a pie chart that shows male versus female, for example. Like that sort of stuff is great. So D3 would be on top of this rather than instead of it.
Do you know if anybody's used this for something other than maps, like scientific data or?
Yeah,
I don't
so
know, like data visualization or something?
I taught a tutorial here a couple days ago, and a gentleman came up to me and talked about some scientific data that currently he was using matplotlib to generate, and he wanted to use something like this to go ahead and basically dynamically generate each of those parts and throw them onto a Slippy map. And it's like 5 lines of code to do that. Since he already has the code to generate images, he just has to plug that into TileStash, which will get him everything else for free.
Okay, great. Thank you very much. We're going to have a 10-minute break before the next.